So I'm going to talk about one of the most exciting topics in the world, security of both the Internet of Things and smart cities. And hopefully we'll get the presentation up quickly so I can try to stay on schedule. So just a little bit about Sypris, our background. We're a US-based company. We've been involved in military-grade encryption and products since 1960. And we also have a commercial side, and that's really what we're here to talk about today. Maybe I'll turn my phone back on and I'll talk from my slides. The first thing I was going to talk about basically is the PKI architecture, how we're doing things today. All right, so basically when you look at the PKI architecture, what you have is you have a lot of keys that are being protected at a lot of locations. If you take a normal infrastructure, let's just take a credit card example, even though it doesn't really need to be a credit card. You basically have a person who has some kind of card, some kind of object or token or something that's going to represent its identity. You have to basically send that identity over to the registration authority, and then you have to, and then that registration authority says that you are who you are. They check your ID of the device or whatever it is, right? And then they send it off to the certificate authority, and the certificate authority then assigns you an identity, or your device assigns an identity and a protocol, and then basically then at each of those two locations, there's keys that have to be protected that represent those identities. All right? Then basically, once the certificate authority basically says, okay, we're going to sign off that you are who you say you are, then it's basically sent off to the validation authority. The validation authority is what has the public-facing interface. So if you want to validate someone as who they say they are, or that someone has the right credit card, the store, the person, whatever, is going to interact with the validation authority and basically agree that you're talking to who you're supposed to be talking to. And that's kind of the whole chain of trust. And at each of those locations, you have these nasty little red safe symbols here with a key in it, and you have this key that you have to protect. So one of the problems is this is very costly infrastructure. When we start talking about how we're going to scale this to billions of devices, you have a problem. All right? And the problem is, okay, you have to protect the key. That's the most important thing. That is your identity. All right? So how do you assign billions of devices identities without increasing the attack surface? Because you have to start thinking about from production to the endpoint and the customer. There's lots of breaches that have occurred just because of the manufacturing process. A very famous one is RSA tokens that were used for high security for the email systems, right? They basically had a production system where they're assigning values into these little tokens where you carry around with you, and it has little numbers on it that change once a minute. Okay? Well, someone got access somehow, some way to that data, and they're able to utilize that data to break every single token, and no one knew it. That's one of the other horrible things about these keys is you can never tell when someone copies them. So once you've been compromised, you really have no idea you've been compromised until something else triggers. So we have to be careful that we're not increasing the attack surface as we try to assign billions of identities. And of course, we're creating lots of extra communication links. The point of the Internet of Things is, in smart cities, is for everything to talk to everything. All right, well, if everyone's talking to everything, you just opened up all kind of communication paths. Forget firewalls, all those other things. Really, did I go off? Okay. I'll stand here. Basically, they become less and less effective because you have so much open comm links. And so then you also have things like you have to refresh the PKI certificate every couple years or something if you want to stay safe because you don't know who copied that certificate and who stole your key. So these things start to really add up, and quite frankly, it just doesn't scale. All right, so what we really need is we need devices to have an intrinsic identity. It has to have its own identity. And then we have to include security, otherwise you won't know the value of the data. Anyone can imitate anything. If I want to go real fast to work one day in his example there, I'm going to make all the lights turn green for me because I figured out how to hack the traffic lights to ignore all the other cars, and I'll have a great drive to work. So our problem is, right, we just don't really have a scalable solution right now. You cannot treat the networks as trusted. Even in companies right now, everyone's bringing their cell phones in. You have Bluetooth. You plug your cell phone into your computer. Firewalls, they're great. Big analytics is great. But you're fighting a losing battle where you just have to start not trusting your networks, even inside your own companies. You have to depend on endpoint security. And the other reason you have to depend on endpoint security for IoT is because you're supposed to have endpoint to endpoint talking to each other, not going through a central server. So how are you going to talk to each other and share data in a reliable way if you don't have trust? And clearly you have to have some flexible security layers because there's never one solution for everything. So key point here, 95% of all breaches in 2014 was basically someone taking an identity. So protecting that key is the most critical element. So what we're saying is that the silicon-based identity is really what you have to have. You have to figure out a way to base the identity in the silicon of the system. You want it to be non-transferable. You want to have it so no one can clone it. And you want to eliminate the cost and the structure around it because you can't afford to manage it. So this is a picture of complexity and security. Real simple picture, right? As you go into higher layers, you go to your, the big internet and internal networks, you have computers, applications, you have all these different layers, operating system. At each of the higher levels, basically you have a much lower level of security. And that's just because you have complexity. Once you have complexity is the enemy of security. To make something secure, it has to be really simple, really short, and attestable. So the reality is the most testable thing in that model is down at the chip level. You have a very small attack surface. You can thoroughly test it, and you can build an intrinsic identity into the silicon, which is what we said we just needed to scale to billions of devices. Here's the problem right now. If you start on the left side, my mic's back on. Good, I can walk. Okay, so if you start on the left side, all the advantage right now is to the attacker because they can basically sit anywhere and attack your system and you don't know it. You're trying to do big analytics. You're putting virus scanners in. You're buying these fancy firewalls. It's great. You're spending millions of dollars while the guy buys a $100 PC and hacks your company. Basically, the revenue model doesn't work. You have to get to the point where your cost to attack is more than it's worth to the person attacking you. If you can't get to that point, you will lose because they will always find a way in. So what we're saying is you have to have that extracted hardware identity. You have to reduce the attack surface so your security is at the endpoint because it's the only affordable place to have it. Some examples of today's world, right? The Target hack. Basically, as I was creating this presentation, I was thinking, well, that's really probably our first example of an IoT hack that really cost a lot of money. I think Target estimated their losses at $170 million. It was a great system, right? That you had a AC company that was controlling their system. They wanted to do maintenance and monitoring to find out whether things were working right. Well, okay, it's a little small 10-person company. Guess what? Their IT security probably isn't the best. They got hacked. Well, Target had given them a nice entry point so they could go monitor the AC system. So they used their little connection to the AC system, and then they found a way to jump onto some computer. I don't know who it was, someone in the company, and from that computer they got a certificate, and they just kept working through the system until they basically sat there for many months stealing credit cards without anyone knowing. Cars are being hacked right now through the cell phone network. There's plenty of examples you can go look out there that are public now. They're controlling things like brakes, the steering wheel, turning off and on the engine, changing the gauges, remotely from their little hotel room or wherever they want to be, and they're taking control of cars. Planes are being hacked through the entertainment system. Medical devices, you would think, medical devices would be pretty secure. Basically, if insulin pumps have been hacked, someone can basically just wirelessly connect your insulin pump and inject the full amount in your insulin pump and kill the person. Pacemakers, same problem. You can basically control the pacemakers. A lot of these things are really great because the doctors get to implant them into the person, and then they can update them as the person's health changes. The problem is if you don't have security in at the root of trust, you're opening yourself up to a massive amount of liability. And then there's always the privacy issue, which depending on how worried you are about it. I mean, I think almost everyone now carries around a tracking device with them. So at every point in time, someone knows where I am, what I'm doing. So I pretty much gave up on privacy. So what are the security requirements? Okay, so security is only as good as the key is protected, number one. We have to have a smart management method for key management. You can't scale something with the cost factors the way it is today. You have to have a root of trust to have endpoint security. You can't depend on servers to protect you. It's got to be built into the end device. And then, of course, that includes something that a lot of people forget, which is secure boot and secured update. A lot of people can make secure systems, but then they'll leave their upgrade port or JTAG port open on their devices. And when you have these devices out in the public, the Internet of Things devices will be in the public. Someone can just go over there, plug in, change the code that runs on the processor, and you never know it. All right? And then, of course, there's the rules of information assurance, which I'll just skip over for time, but they're all important. So examples of the scalability we have to worry about. So they're expecting 39 billion devices, whatever, in 2020. Everyone can argue over what the number is. I thought it was interesting. The Airbus 1000 they're working on right now has 10,000 sensors per wing. A typical car has 80 ECUs in it right now. Basically, you have to have endpoint protection. You can't assume that every ECU in that car is going to be safe. You don't know if someone has installed an ECU in one of those elements that has been compromised at somewhere in the supply chain. You don't want things like your entertainment system or your cellular network telling your brakes not to turn on. Oh, and one last point that's important for the Internet of Things, and that is you have to have security at the endpoint, but there's also the collector. Sometimes the endpoints just aren't smart enough. They just don't have enough horsepower in them. So at the collector level, you also need security. And depending on your system design, it can be in one of those two places, in my opinion. So you have to have, that's one of the sad things about security, it has to be a holistic approach. No one likes that because it's only as secure as the weakest link. So if your production line that assigns the key happens to have a USB port that someone happens to copy and happens to send off to someone else, that's your weakest link. You spent all that money building up all your great AES encryption and everything else. It didn't do a lot of good because someone just stole the keys from you another path. Okay? You have to have a secure command and control of your endpoints. You have to have a way that your endpoints know what they're allowed to share. Are they allowed to share the data with anything that wants to talk to them? How are they going to decide? Are they only going to be allowed to talk to the collector and maybe the smarts in the collector of what it's going to decide? Or as it pushes up to the cloud, is it going to be made later? So what's the path to success? Okay, so security has to be solved for broad acceptance of the Internet of Things. There's a lot of liability that's occurring right now that I don't think people realize. Unfortunately, the sell of security a lot of times is the total life cycle, which no one wants to worry about. When you're an innovative company and you're making new devices, you want them to be cool, fast. What you don't want to talk about is the long-term life cycle cost to an end company, like Target. I bet you Target would have said, you know what, I'd rather my air conditioner break once in a while than pay $170 million so my AC guy can not bother driving to my store. I think the companies have to learn and understand their liabilities, because with these demonstrations that are public about the vehicles, medical, you name it, right? There's real true risk there that sooner or later is going to happen. And I think, obviously, you have to have a good business model, so I threw that one in there. You have to have a way that you're creating value. It's nice to make cool things, but if you're not creating value, then there's really no purpose to what you're doing. And the last point, which I think is most important, because security is so hard, you need silicon providers and system providers to basically build in a security architecture and a framework that allows the engineers to make secure systems without fully understanding all the security. I know that's a dangerous statement, but if you start thinking of engineering reality, all right, and this, I love this diagram. It's one of the IEEE and ISO standards, right? And it is totally correct, but when you read that, that is your architectural model of how to make a safe Internet of Things product, right? So you're a small team of a few engineers and you're building a product. What do you do with that? Does that mean you need secure boot? Does that mean you need to protect your key? Does that tell you how to protect your key? Does it tell you how to interact with things? The problem is it's just too complex. It's not consumable by who's actually building the devices today. So I think that as the bigger companies start to build frameworks where it makes it easier for the end engineer companies to make secure solutions, those companies are the ones that are going to really be the leaders in IoT. That's just the IoT stack. I'm just trying to show that the identity starts at the physical object, and then the reality is there's in the full stack here, you have the people that share the data in the middle, then you have people that do the analytics, and then you have your dashboards at the top. The reality is you need identity at all those areas. A great example, we're working in the Boston area. The fisheries are doing a lot of things with the Internet of Things. If you tell the fishermen that they're going to start using the Internet of Things and they're going to provide their GPS location back to as to where their fishing holes are, they will not agree. They believe that is their crown jewels. They would never tell anyone where their fishing holes are. So as you start to share these things, certain people are going to want control over what information they're sharing and how they're sharing it. However, the government might want to know how many fish are caught in general areas. So the government may want to get that data, but the fishermen may want to protect how accurate that data is. So there's a lot of decisions that have to be made. All those decisions of how you share require the identity of both the source and the processing path. So again, we have to build in identity into all these objects so that we can manage it and make it usable and control it. We have a particular technology that we've been developing called Symetrics. It's our play on words for Symetrics, biometrics. And basically, it's a way to extract identity from silicon. We believe that's one of the paths. You can also assign identity in a normal PKI, but as we said, we don't believe it's very scalable. And you have to remember to be standards compliant. That's one of the problems. You can come up with some new methods, but if you're not working in today's infrastructure, people just won't accept you. And I'm just going to kind of skip through this. These are the basic elements of what you need for a secure stack, right? You need crypto processing. You probably want encryption. You want secure upgrade. You want trusted boot. You would like side channel attack protection. You'd like tamper protection. These objects are out in the public. You don't want everyone being able to just get into them and changing them if you're going to depend on them for your systems. So those kind of give you all the elements you would need to be secure. The other thing you're going to have is you're going to have different circles of trust that you probably want to create. You have your endpoint devices that could likely be changing more often, the sensors that you're going to have at the endpoints. Then you're going to have your collector points. You're probably going to want all your collector points to have some relative trust among themselves. Then you're going to go up into the cloud and your building structures and produce your web interfaces and RESTful interfaces and so on. At each of those levels, you're probably going to want to create an architecture where you have levels of identity and levels of trust so you can manage it in a proper way. Because the endpoint's going to be too dumb to know where its data is allowed to go and where it's not allowed to go. So you're going to have a more systematic approach. This is an example of Smart City. We're working with the Singapore government, and one of the things that we're doing there is they're putting these light poles around. And in the light poles, they're planning on having Wi-Fi, sound, video. And so our partners that we're working with and us are working on solutions of how do we secure this. They're obviously going to be available. People can take the pole and hack into it, and you would like to know the video came from that pole. You'd like to know someone's not playing false video to you. There's other legal aspects is, for example, that video coming from that light pole. Can you bring it into court and prove that something happened? How do you know that video came from that pole? Is there signatures on the video? How legally does it hold up in court? So there's lots of complex questions. It all goes back to having really good identity and protection of the devices so you can use the data. This is just an example that some of the sensors are probably smart enough to have their own identity, and then you have the collector element. The identity here is represented by that little symbol. And some of the sensors are probably just too low end. They really can't have their own identity, and then you have to depend on the collector to provide them their identity. Okay, and then the conclusion. I have 3 seconds left. Wow, pretty good. Oh, I just went over. Okay, so it requires a hardware root of trust. Hardware, because as the lowest layer, one of the things I didn't point out, that layered map I had of all the different layers of complexity, if at any point you compromise the layer below another layer, the layer above it's done. You fully control it. So the real truth is you have to have the hardware root of trust. You have to have the endpoint security. You have to have intrinsic in the hardware an identity, because you don't want to be assigning it and managing billions. And how do you manage a company goes out of business and they have all these devices out there? Who's going to update their certificates anymore? What do you do with those? How do you know they're secure? So again, our belief is through partnerships. There's no one company. We're working with a lot of companies in India, in Boston, and some in Singapore. We're trying to create a consortium where we're building some solutions where we're getting security framework built in, because we think that's really what's going to make things take off. Thank you.